Today I'd like to work on a little bit of equations, help you out a little bit, see if you can duplicate this. It's just going to be a real quick lesson. The first problem is up here. It's a fraction times a fraction, and if you'll notice that there's two negatives, that will make a negative times a negative is always a positive. So in this case I don't need to worry about a sign out here because it'll be positive, but I can do reduction. 3 fits in itself once, and 3 fits into 6 twice. Half of 12 is 6, and half of 10 is 5. So my answer is going to be 5 times 1, 5, and 2 times 6 is 12. So I have 5 twelfths. That's the first example I'd like to show you. Next, we're going to move on to another example. It's a little more complex than the last one. So we're going to look at 49y to the 4th power. This is going to be a negative fraction over 6. And we're going to multiply that by 3 over 21y to the 3rd. Okay, in this case, we're going to look at reducing the whole numbers first. So we could start 7 fits into here 7 times, and 7 fits into here 7 times. And then I'm going to look at 3 fits in itself once, and 3 fits into 6 once. So I know right away that I have an answer here, and it's a negative times a positive, so it's going to be a negative result. And I have 7 times 1, so there's a 7, and I have 1 time, whoa, wait a minute, this is a 3, sorry. 7 fits in there 3 times. How would I manage that? Anyways, 3 times 1 is 3. And then the next thing I have to look at is I have to look at the values of the y variable and reduce those. So I really have y to the 4th power over y to the 3rd power, which is really y over 1, or y. Here's a better way to explain it. I have a y times y times y times the y all over y times y times y. These are ones. 1, 1, 1. 1 times that y is the y on top. So this is how we get it. Or the rule says if I have y to the 4th power and I bring this up, it's minus that power. So then all I have is y to the 1st power, which is y. So maybe that's even a better explanation for many of you. It's simpler anyways. Let's think of it that way. The next object that we're going to look at is 4x to the 6th power divided by 2x squared over 5. Now let's create a fraction on this side. Any whole number over 1 is a fraction. The next thing we have to look at is we do not divide fractions. We multiply them by a process. The process is called using the reciprocal of a number. So it really just means that you flip the number over, it's its reciprocal, and then we can actually manipulate the problem and finish it. So now I can reduce, because in this case, if I look at it, 2 fits in itself once and 2 fits into 4 twice. So 2 times 5 is 10, and 1 times 1 is 1. And then my next step is to say, well, I have x to the 6th minus the 2, so now I have x to the 4th. So my answer is 10x to the 4th power. That's a shortcut to get there. You could just go minus 4, and then you will at minus 2, sorry, and then you'd see where it came from. Moving forward to the next example, we're going to look at 2 over 3x added to 4 over x. Well, in fractions we learned that we have to have common denominators. I can leave this one the same because my common here is the 3. I got to get a 3 on this side somehow. So what I'll do is I will take this fraction and multiply it by 3 so that I have the same denominators. This one remains 3x plus 3 times 4 is 12, and 3 times x is 3x. Now I can combine like terms on the top, right? I have a number and a number, which is 14. Whoa, I don't know how that happened. Should be 14 over 3x, and I can't do any more than that. Sorry for that. We're using a new system here. Learning just like you. The next thing we'll do is look at 1a added to 3 over b. Whoops, the dyslexic person, it's a b. We'll just do b, okay? So, a little messy. We're going to try again. 1 over a plus 3 over b. There. Now, the common denominator is a times b, which is ab. 1 over a has to be multiplied by b over b. And then we're going to look at 3 over b needs to be multiplied by a over a. So I have b over ab added to 3a over ab. So my end result is going, these are not, look at this, these are not the same thing. So I can't really do much more other than simplify a little bit. B plus 3a all over the ab. That's my simplest form. Either form is correct, but this is the simplest form. Couldn't combine those because they were not like terms. Now let's move forward and look at another example. We have 10 over 13, 10/13, divided by 14 39ths. Now this can be written so that it looks a little friendlier to you. And it's just 10/13 is divided by, so put it this way, 14 over 39. And in fractions we learn that we don't divide a fraction. What we do is rewrite the first number, and we make a multiplication problem out of this piece by what? Flipping over the number, which is called the product of reciprocals, and now we can reduce. And I could say half of this is 5, and half of this is 7, and then 13 fits in itself once, and 13 fits in here 3 times. So now what do I have is 3 times 5 is 15, and 7 times 1 is 7. Now this is a state we'll leave it in because it's pre-algebra and we use our numbers this way. It can be converted into a mixed number, but we won't take the time to do that. The next thing we're going to look at is the same kind of problem, except it will be in a variable in it now. X to the second power over 4 divided by x over 8. Again, I would encourage you, write it like something you're used to seeing, x squared over 4 divided by x over 8. Apply the rules for fractions, x squared over 4 times 8 over the x, because what did we do? Product of reciprocals. Now we can reduce. 4 fits in itself once, 4 fits in the 8. How many times? Twice. So I know I have a 2 left here on top. But then I'm going to subtract x fits in itself once, and it's 1 left in here. So I have 2x left. Hopefully that's clear and you understand that process. All right, moving forward, out of division to a more complex type of problem, we're going to look at x over 2 to the 3rd power equals 3/8 plus 1/4. The order of operations states that parentheses exponent, so I have to do the exponent first, which this is an 8 because 2 times 2 is 4 times 2 is 8. My next step then is to look at 3/8 plus the 1/4, and I have to have a common denominator, so this one needs to be multiplied by factors of 2. So now I have x to the 8th equals 3/8 plus 2/8. So now I have x to the 8th, and I can sum this side. 2 and 3 makes 5 things out of 8 things now. The next step is to get rid of this 8 here. In order to do that, I have to multiply by its reciprocal. This is really a 1 over 8, so now I have to have 8 over 1 on this side. Keeping balance of the equation requires that we need to move to this side and keep the balance. This becomes a 1 on this side. 1 times x is x, so x is alone now. And then I can reduce this 8 with this 8. 5 over 1 is 5. And that's a quick review of how to do that type of a problem. It looked kind of beastie, but it's really not that difficult. The next type of problem I'd like to do is an extension of what you kind of already did. We have this opposite of 5/12x equals 15. Again, how do we get rid of this side? This side is just simply take what you know from fractions, multiply by the reverse, the inverse of it, which is the product of reciprocals, and then do exactly the same thing over here, and I'll put this over 1 so it looks like a fraction. We have the opposite of 12 over 5. This all reduces out here to be a x. Negative times negative is positive. 1 times x is x. And then on this side we can reduce just take 5 into 15 3 times. 3 times negative 12 is the opposite of 36. One more, and that's about what Chapter 5 is really about, are these concepts that I'm putting up here right now. 8 over 11 minus 1/5 divided by 11/25. First step, order of operations, is division and then subtraction. I always think of subtraction and addition as a stop sign. So 8/11 remains here, minus 1/5. Create a multiplication problem by the flip it over rule, remember? And we'll have 25, it's called the reciprocal, right? Over 11. Now let's reduce if we can. And in this case we can reduce. 5 fits itself once, and 5 fits here 5 times. So I have 8 over 11 minus 5 times 1 is 5. And 1 times 11 is 11. If I had $8 and I spent 5, I have $3 left. And it's a fraction, so it's over its base. Thank you. Hopefully these were helpful tactics for you and that you can use this little demonstration for your own sake. Have a good day.